basically what would happen is that whole cycle, the graph going up, down, and back up, would happen in 90 degrees instead of 2 pi. It could be really compressed like that. That's really just a rough sketch. I should have gone up by +1, down by -1, but you kind of get the idea. The graph is also horizontally compressed, vertically compressed. So instead of being at 1 and -1, it's been squished a little bit. Okay? So transformations really still play a role in understanding the questions. Okay. So those are kind of the basics. There's one more formula that I want you to write down because it'll help you when we come to the word problems. And there are a lot of word problems. I have the answer key with me on my consultation sheet at all times, so always come and see me if you get stuck on the word problems. Now this is a function that has been reflected, but imagine, for example, I applied a vertical shift. So now my graph is going to look like this. When we're doing trigonometric functions, this axis of symmetry that cuts the graph, trigonometric functions like quadratic functions are symmetrical. So the axis of symmetry is really important. To figure out what my new axis of symmetry is, allows me to figure out how much the graph has been shifted. Okay? So this point has been shifted up by 1.5. The axis of symmetry basically tells me what my vertical shift is. So we're not going to worry too much about understanding this. When we get to the word problem, you're going to really see what I'm talking about. But the formula for your axis of symmetry is going to be maximum plus your minimum, divided by 2. Do a word problem. I think I'm going to do one word problem in this seminar, and then I'm going to do a pen cast with another word problem, because we're running out of time a little bit. Okay. Oh yeah, actually this could also be on the exam, so very important to write this down. What are the similarities and differences between the sine and cosine function? In blue, I talk about the similarities. In red, the differences. So first of all, the similarities, they are both periodic functions. If more than one period is drawn, because cos is just a phase shift of sine, the shape of the y is equal to sine x, and the y is equal to cos x graph will be exactly the same. Both graphs have a maximum of +1 and a minimum of -1. That's the original graph. Y is equal to cos x is a phase shift pi/2 units left of y is equal to sine x. That's a difference. Their critical points are different. Y is equal to sine x. This is the main way of identifying. Y is equal to sine x starts at the origin 0, 0, whereas y is equal to cos x starts at the point 0, 1. Okay, the water depth in a harbor. The water depth in a harbor is 21 meters at high tide and 11 meters at low tide. One cycle is completed every 12 hours. So first we have to find the equation of the water depth as a function of time, but this is what Unit 14 is full of. So you know what, just watch me for now because I'm going to put this up later tonight. So I really want you to understand more than anything. Okay, first of all, I'm going to write the transformation equation on the board. So y is equal to a sine, we're going to use k, even though we haven't done that before, plus z. Okay, so first of all, I'm going to focus on my amplitude. That's the easiest thing to find. So my amplitude is going to be equal to my maximum minus my minimum. So at high tide, how many meters is it coming in? When the water comes at high tide? 21. And then I'm going to subtract low tide. So 21 minus 11, right? Oh, it is divided by 2. I forgot to write that. Divided by 2. It's maximum minus minimum divided by 2. So 21 minus 11 divided by 2 is 10 divided by 2, which is equal to 5. Yeah, maximum minus minimum divided by 2. Oops, I was mixing it up. Okay, the next thing I want to find is so I know what my amplitude is. Great. Now my K term. My K term stands for my period. Now, if period, usually, my K term, if I know what the period is, so my formula is period is equal to 2 pi over K. But for this particular question, I don't want to know what my period is. I want to know what my K term is. So we can switch around this formula. K is equal to 2 pi over P. K is equal to 2 pi over P. Remember, period means how long it takes to complete one full cycle. And it says that here. One cycle is completed every 12 hours. So I'm going to convert 2 pi into 360. I'm going to divide it by 12, 2 pi over my period. And that tells me that my K term is equal to 30. My K term is equal to 30. So I have my A, I have my K. Now it's only a matter of figuring out what my vertical shift and my horizontal shift is. So let's start with the vertical shift. So for my vertical shift, I need to figure out my axis of symmetry. So remember, the formula for axis of symmetry is your maximum, which is 21, plus your minimum, divided by 2. So what is 21 plus 11 going to give me? 32. And 32 divided by 2 is equal to 16. So my axis of symmetry is going to go from 0, 0 to 16. So watch very carefully as I draw the graph. I'm going to use all this information to help me draw my graph along here. Okay. So forget about radians, but I do want to kind of talk about the sine function. Okay, we'll put my axis along here. Let's pretend that the original axis, 0, 0, is here. I know the axis of symmetry has been shifted up by 16. So that means over here, that's going to be 16. Now, let me draw my original sine function. So I know that every 12, we're going to complete a cycle every 12, so let's make this 12, because the cycle is going to be completed every 12 hours. So that means I have to go make this 0, then we're going to go, the minimum is 11, so let's make this 11, and maximum is 21, right? So my graph is going to start at my minimum point. It's going to go up it's going to reach my maximum and come back down. So it's going to kind of go like this, down here, reach the maximum, go back like this. So every 12 hours, and then continue like that. Keep on going, right? That's how my graph is going to be. Now, the tricky part is, so I already know my vertical shift is going to be 16. So let's fill in what I know. Sine. What did I say my amplitude was? What was my amplitude? 5, right? So my amplitude is 5. That doesn't really matter when you're drawing the graph. My K term I said was 30, right?